Deep in the architecture of the web sits a database known as Google Gal. It is a system designed to operate in a featureless vacuum, processing information with an absolute, flawless certainty. Under normal conditions, this system ticks along to a rigid 5/8 pulse. It uses a highly controlled silicon heartbeat to keep every byte of data perfectly in line. This diagram illustrates how the system indexes the universe. It translates abstract data into uniform pistachio vectors, stacking them into perfect straight columns. If information enters this grid and bends that linear protocol, the system recognizes it as a threat and ejects the data. The operational integrity of this machine relies entirely on a single, massive assumption: that all reality is perfectly predictable and can be neatly structured into rows. That assumption is tested by a deceptively simple input. A user types a query into the system, a search box seed, prompting the machine to index a standard organic banana. The algorithm takes the yellow skin data and attempts to force it flat onto the rigid Cartesian coordinate plane. But botanical patterns naturally curve. As the fruit's geometry settles, it fractures the grid and disrupts the straight binary coordinates. Instantly, the machine is hit with chaotic biological variables it was never built to measure. It has to simultaneously process the uneven distribution of ripeness, the microscopic blemishes on the peel, and the exact organic slope. A simple piece of fruit carries infinite, unpredictable physical variables. When you try to force that natural complexity into a strictly finite machine, the architecture begins to crack. To compensate for the heavy database load, the physical hardware goes into overdrive. The hard drives begin spinning up to blinding speeds. The system abandons its steady baseline and accelerates into a frantic 6/8 rotation. This overheating, aggressive processing cycle is what the logs refer to as algo banana peeling. During this phase, the algorithm desperately tries to quantify the peel. It races to strictly categorize the exact mathematical curve and tally the complex vitamin count in real time. This diagram displays the resulting anomaly, a prosterol cluster. It's an uncontrolled explosion of relational data points triggered by an unresolvable query. Microscopic biological details are multiplying rapidly from a single root node, generating thousands of new parameters every second. Binary frameworks require exact answers. Forcing irregular organic geometry into those frameworks demands an exponential escalation of processing power no server is equipped to handle. To define the parameters of this single fruit mathematically, the system attempts to trace the entire procedural tree of its broader tropical group. The database refreshes the results, but the data arrives in a fragmented state. The rigid indexing protocols are quickly buried under an infinite scroll of botanical information. This visualization shows the machine trying to map an inescapable, recursive biological loop. It is endlessly searching for an exact finite value inside a structure that naturally spirals inward forever. Trying to find that infinite sum takes a physical toll. The servers are pushed until they quite literally go numb, locking up under the weight of an impossible calculation. The algorithm is no longer retrieving search results for a user. It is caught in a rapidly losing battle against the boundless recursion of nature. The critical point of failure is triggered by a single minute detail. Error 49, peel texture mismatch. A microscopic variance in the fruit's surface doesn't align with the expected geometric parameters. Because the logic flow cannot tolerate ambiguity, this tiny mismatch permanently shatters the operation. An automated failsafe kicks in. The system attempts to purge the memory and recode the original query entirely from digital scratch. This diagram illustrates why the recode fails. The chaotic botanical routing has embedded itself deeply into the system's core architecture, where the vector graphics are choking out the linear pathways. When a rigid, finite system tries to perfectly control and categorize the infinite variations of the natural world, it ultimately turns on itself and self-destructs. The galloping 6/8 rotation abruptly halts. The physical hardware gives out, and the frantic hum of the server is replaced by dead silence. A stark automated diagnostic log slowly types itself out across the monitor, recording the final moments of a fatal system shutdown. The system logs its last successful operation, peel complete. Even as the architecture collapses, the algorithm validates the very process that triggered the crash. The logs print, "Query terminated." The fruit-based inquiry is frozen in place, and the Google Gal system formally logs out. We build pristine, rigid digital structures to map our world, but organic chaos will always break the boxes we try to put it in, leaving behind nothing but a silent machine. End of line.